Today we would be discussing about Lorentz force, motion of charged particles in electric and magnetic field.
Lorentz force. Lorentz force is a law discovered by a Dutch physicist, Hendrik Antoon Lorentz. Lorentz's law defines force that acts on moving charged particles in an electromagnetic field. Force consists of magnetic force and electric force. An electric force is an attractive or repulsive force between two charged objects. Electric forces are attractive when two objects have opposite charges, and repulsive when two objects have like charges. Electric forces are different from magnetic forces, although the two are strongly related.
Magnetic force. As a charged particle interact with a magnetic field, they will experience a depleting force. This depleting force is greatest when the velocity of the charged particles is perpendicular to the magnetic field, becomes less at other angles, and zero when the velocity is parallel to the magnetic field. The direction of the depleting force is always perpendicular to the plane described by the direction of magnetic field and the velocity of moving charges.
If the charge is positive, the direction of the electric force is equal to the direction of electric field. Lorentz found out about magnetic force. Magnetic force F sub B is equal to vector equation Q times V cross B. And if you look for magnetic force in magnitude only, it will become like this. Particle that has no velocity, if it is not moving, there is no force. But as it moves, it has a velocity vector, and if you're ever moving as a change through a magnetic field, then you're going to have a magnetic force applied to you, and we call it the magnetic force. Okay, then. Now, things you need to remember is that it's a perpendicular line between the magnetic force and the magnetic field. But the velocity vector in the magnetic field vector don't have to be perpendicular to each other. How do we calculate the magnetic force? We have three things to consider. First is the charge, next is the velocity, and the last one is the magnetic field. This explains the right-hand rule. As you can see, as the magnetic field goes in this direction, and the velocity in this direction, the force is going upward.
Go!
Example, magnet in a screw. This example shows a magnet in a screw spinning through the Lorentz force. Magnetic field comes straight up out of the magnet and the electric charges is moving inward from the wire to the screw. The force shown in this diagram, is at right angles to both, causing the whole thing to spin.